Okay, so this is going to be on complex resistors, complex circuits. The first one we just had like all series, all parallel in the same circuit. Now we're going to have both series and parallel. And I'm showing you this beginning just because it's a bit messy, and even the simplest of ones could get a bit messy. We're going to work through this step by step. Here would be the last kind of step, depending on how you look at it. So you're going to need multiple sheets of paper. You're going to need to remember the two concepts. In a series, currents are the same. In parallel, voltages are the same. Okay, and we're going to use that just over and over again, and just keep using the same Ohm's law. V equals IR, V equals IR. You just got to know what V, what I, and what R to put in. All right, so that's what we're going to do. First off, the wind doesn't blow my papers all over the place. I'm hopefully going to give a little more space here compared to what I did for mine. All sorts of pens all over the place. So first off, somebody would say, where did this come from? I just made it up. Oops. Okay, and we'll call this one R1, R2, R3, R4, and R5. Okay, now what you'll see on people's, if you ever watch any videos or look at anybody's online stuff, and I would do this too, I didn't do it in the last video because they were pretty simple. Basically make a table. R1, 2, 3, 4, 5, and then we would list like the resistance of each, the voltage of each, and the current of each. Pretty terrible drawing. Okay. And I guess we could make this a little nicer and kind of box it. Okay, so I just gave these some arbitrary, doesn't really matter which ones you pick because it's not a specific circuit. But for us, we're going to go 2 ohms. R2 is 3. R3 is 4. Truth is, if you didn't want to put the 4 in, or the ohm sign in there, that's fine. We should probably just put it up here. That'd be a lot easier. R4 is 5, and R5 is 10. 10.0 is fine. Okay, so, and we're going to give this a voltage of 12 volts. Now, 2 other things that we might have here is we want to find the equivalent resistance of the entire thing and also the total current. We'll get to that at the end or beginning, depending on how you look at it. All right, make sure I'm actually on the screen here. Okay, so we have multiple situations. Okay. If we look, this one would be parallel with, this one would be in series with this whole thing, which would then be in series with this one. These two are in series, but they're parallel to this one. So where do we begin? I think just the more and more you get used to doing these, you'll find like a good spot. So like, how could I put these all in series when this has this combination here, right? How could I put these in parallel when I don't know what this single one is yet? Okay, so it's kind of obvious to me we have to start right here. There's no way, simple way that we can just like do like a series R1 plus this plus this. It'd be very complicated. So what we'll do is make a series of pictures, and basically the idea is you make picture after picture after picture, dwindling the circuit down to look more basic, and then we'll work our way back up through the pictures to get these values. Okay? See if that makes sense after I do the next drawing. So we're still going to have our same setup here. we go to R1, we split, but now this right here is going to become what I call R23. This is still R4, and then they come out and they go to R5. Still 12 volts, okay? So I took these, and they were in series, and I made them into one. I can't tell if I'm ever on the actual screen. So I took these two and turned them into one, R23. Now how would we find the voltage of this? I'm sorry, the total resistance, the equivalent resistance of this, okay? Well, it's not too bad. So R23 is just going to be R2 plus R3. Remember, if we are in series, we just add them up. So R1 is 3. I'm sorry, R2 is 3, and R3 is 4. That would give us 7 ohms. Okay? And we're going to need that. Okay? Sometimes you might see people just draw the pictures and then do all the math later. I kind of draw the pictures and do whatever math I can. So we're going to keep finding these resistances as we go down and make simpler and simpler drawings. Okay? So now if we look at this whole setup, I'm going to have these and I'm going to make them parallel. They're parallel. I'm going to turn it into one resistor. Okay? So then we go from here into one into here. It'd be a series then. These are in parallel though. So how would I do that? Matthew, I don't care. So we would go R1, and then we would go, this is where, what do you call this? On my sheets, I call this R2, 3, 4. And then we go R5, okay? So hopefully we could see that maybe here. And this will turn into this right here. Okay, so how do we do that? So they're parallel. So 1 over R2, 3, 4 was 1 over this plus 1 over this. So 1 over R2, 3 plus 1 over R4. So 1 over 7 plus 1 over 5. Okay, so where did I get that from? Remember, R2, 3 was 7, and R4 was 5. So when you do this math and you do it correctly, you get an answer of, what do we got here, 2.9. Now, am I going to be following really hard on significant figures and whatnot right now? The answer is not exactly. Okay. And then, how do we do this last part? Well, the nice thing is they're all in a series. So, if we make them all into the series, right, it looks something like this. Just one resistor. And that would be REQ. That would be our total equivalent resistance for the entire thing. Okay? So how would I do REQ? REQ would be equal to R2, 3, 4, right here, plus R1 plus R5. I don't know why I didn't put R1 first, but R1 plus this, it doesn't matter. They come out to be all the same. So it's 2.9 ohms, R1 is 2 ohms, and R5 is 10 ohms. So our equivalent resistance is 14.9 ohms. Okay. So when I do this, I like to actually go back. When I find something, I go back and I write it in. Okay. Now what else could I find here? I'm going to do this in green. I could also find the total current. Okay. So this is 14.9. Now I'm going to find I total, which is just the current at this situation. All right, and so V equals IR. That's the total voltage, which we have here. It's equal to the total current times the equivalent resistance. Okay. It's equal to V divided by Req. So our voltage was 12, and our equivalent resistance is 14.9. So our total current should be 0.81. Is that right? I'll look back at my other paper. Yep.
This is the last one.
0.81 amps. So I'm going to go back to my very beginning where I made my little chart. All right. So basically now we're at the very end, and now we're going to work our way back. So we're going to go figure out all of these, and then we're going to take that information to find out these and these. Okay? Now, what do we know in this situation here? The voltage drops for each of them are not going to be the same in series, but the currents will be. So whatever the current is here for our equivalent resistance, it's going to be the same for all of these. So I1, 0.81 amps. I2, 3, 4, 0.81 amps. I5, 0.81 amps. Okay, so that's pretty good, right? We could already fill in some stuff here. So R1, 8.1, and R5, 8.1. Now you notice we can't fill in any of this because this isn't just one resistor on its own. This is a combination of other ones together. All right. So now what else could we find? So now you can actually calculate the voltages for these two, the voltage drops. We have the current, okay? We have the resistance. This 12 doesn't matter, right, at this point. That we're not going to be paying attention to that. But the current is 0.81, the resistance is 2, and we could find the voltage, so that's what we're going to do. So V1 is equal to I1 R1, 0.81 amps times 2.0 ohms. VI. I put VI. That's way back from the beginning of the year.
Don't touch it.
What do we got? 1.62. If you just make it 1.6, that'd be fine. Volts. Okay? That's not I, that's a V1. Now, V5. Current for the fifth one, and also the resistance. 0.81 amps times the resistance is 10 ohms. So V5 is 8.1 volts. Okay. So we'll come back here and we could put our voltage in for the last one, 8.1 volts, and our first one, 1.62 or 1.6 would be fine. Right. Now, question would be, do we have to do this? What are you doing?
Oh, Malachi had a tick on it. I just got it off, it fell.
So we have to find the voltages, voltage drop for this one together, and we could do that. So V 2, 3, 4 is I 2, 3, 4 times the resistance 2, 3, 4. Now this is where it gets a little tricky because it's like accounting. You have to like make sure all your numbers are in good places and you're looking at the correct ones. So our current is 0.81. Now what was our resistance? Here it is right here. 2.9. Was it in him or just on him?
It was like barely.
Okay. So our voltage would be 2.35 volts. You can make it 2.4 if you would like. That's fine. Now, why do we need that? Okay. Why do we need that? Well, we know when we get back to our picture here, I wish we had a bigger screen or it was on a big board. Makes it a lot easier running on a big board with this. So here's our 234, which is this one right here. Okay? And so we know if this combination has a voltage of 235, that means the voltage for this one would be 235 and the voltage for this one would be 235. I'm going to write those in. All right. So the voltage 2.3 is going to be 2.35 volts. And also the voltage for the fourth one is 2.35 volts. Okay. Right? They're parallel, different currents, same voltage. So see how we're kind of going backwards now? And now we're on this part. Okay? We're done with this other page. We figured out the current, we had the resistances, we figured out the current, resistance, and voltage for each one of these. Sometimes it might help you to put the numbers next to it. You'd see that on other people's, maybe on YouTube or whatnot. All right, now we're back to here. Okay, right here. So can we fill out anything in our chart? Yep, I know my voltage. 2.35. Okay. But I need to figure out the currents for both. Okay. Now, you would ask, why do we need the current for this one? Right? Why do we need the current for this one? Because, look, the current up here would be the same for both. So even if you're like, well, I don't need it here, that's fine. You're going to need it later. So my suggestion is you find V, I, and R for every single one. All right? So we already have this one completed. We already have this one completed. Let's do R4. Okay? So I4, if we see that, let's do it like this. All right. I4 is equal to V4 divided by R4, right? V equals IR. V4 is going to be 2.35 volts. We just wrote that. And the resistance for 4 is going to be 5.0 ohms. So the current would be 0.47. 0.47 amps. Okay. 0.47 amps. I keep looking back at my other paper and checking. All right, now, that does not mean that this one is 0.47 amps. So what's I23 going to be? It's going to be V23 divided by R23. Nice thing is, see, if we do these on the way down, they're going to be there on the way back. So we know it's 7 ohms, and our other one is 2.35 volts, right? 2.35 volts, 7 ohms. I23 is going to be 0.34 amps. Okay, it's about a third, and that looks right looking at this. Okay, so I'm going to write it up here. When you do it on your own and you're not trying to be like fine for the video, it's a little bit easier. So anyway, now the only thing we have left, see, we got this one, and this one done. Now we need the top two, R2 and R3. And we have everything here we need to know. So first off, the current is going to be the same for both. So if the current for 2, 3 is 0.34, that means the current for 2 and the current for 3 are going to be 0.34 amps. Okay? And we could write that in, 0.34 amps, 0.34 amps. All right. Now we have to find the voltage drop for each one. Okay? We got to find the voltage drop for each one. I'm going to draw it right over here. So V2, I2R2. V2, 0.34 amps times, what's R2? 3.0 ohms. That should be 1.02 volts. Okay. And then we need the voltage for the third. Same current, right? It's in series. Then the resistor is 4 ohms. Okay. 1.36 volts. Okay? And those are your answers, right? So simple. So simple. Is there easier ways to do it? I don't believe so. Okay? I don't believe so. I think it's just you work yourself down into simpler pictures and then you work yourself back following the two principles of currents in series are the same, voltages in parallel are the same. Okay? So you realize when you find a current for this one and it turns into this, that those two currents would be the same. So that's that. Now when you look at people's work online, okay, if you ever look up like answer keys to something, you won't see all this probably drawn because it gets pretty messy and all you'll see is the original and probably a box with the answers. All right? But like I said, this is the easiest thing to do, at least I think. When you have, let's say, sometimes what happens is like they'll say, okay, what's just the current through 4? Okay, and so you have to work yourself down so far to where you can work back and just find 4. Okay, but it's easy if you just find everything and then you can answer whatever question you're looking for. All right. Sometimes they're pretty complicated, like I said. This one's actually a fairly simple one, believe it or not.